In this final video for lesson 1 of chapter 10 in Algebra 2, we're going to be looking at different numbers of permutations when I don't use all of the objects in my particular set. So, in the last example we looked at how many different ways can 10 bobsledding teams finish in a competition given that all 10 of them are going to finish. Now, this next question is a little bit different. It says, in how many different ways can 3 of the bobsledding teams finish first, second, and third to win the gold, silver, and bronze medals? I'm going to ask you to think about this in a couple of different ways. First, if we relate it to what we worked on earlier with the fundamental counting principle, I could maybe just set up a diagram and think about it this way. I've got somebody's going to take first, somebody's going to take second, and somebody's going to take third. And I think to myself, well, how many different teams could take first? Well, that would be 10. There's 10 teams that could take first. One of them is going to, which means that there's 9 teams that will be left that could take second. And then that would leave us with 8 teams that could take third. Being all independent events, I'm going to go ahead and multiply those together. 10 times 9 times 8 equals 720. So there's 720 different ways that we could have a top 3 given that there's 10 teams to work with. Now if we relate this to the idea of permutations, so when we did 10 factorial, that was using all 10 teams lined up in a row. And 10 factorial meant 10 times 9 times 8, but it also then had to multiply it times 7 times 6 times 5 and so on all the way to the end. But I only have 10 times 9 times 8 here. Well, this is still a permutation, just not using all of the objects. What this could be written as, we'll see this on the very next slide, is I could write this as 10p3, meaning the permutation of 10 objects chosen 3 at a time. Okay? The formula that would go with this is right here. The number of permutations of R objects taken from a group of n distinct objects is denoted NPR and is given by this formula. We take n factorial divided by n minus r factorial. Now if I use those numbers we just had, we had 10 bobsled teams and we're going to put 3 of them in order, first, second, and third. Well, using that formula, that would equal 10 factorial divided by 10 minus 3 factorial. 10 minus 3 being 7. So we have 10 factorial divided by 7 factorial. Now, I'm going to write this down here so you can look at it a little bit. Remember what 10 factorial means. It means 10 times 9 times 8 times 7 and so on, right? I could even write this as 7 factorial for the so on part. And if I divide that by my denominator, which happens to be 7 factorial, you'll notice what happens. 7 factorial divided by 7 factorial is 1. So this is going to end up equaling 10 times 9 times 8, which is 720, which is the same thing that we got by using a little bit of common sense. 10 teams for first, 9 for second, 8 for third. Multiply them together, we get 720. Now the neat thing about this is you don't necessarily have to use the formula as long as you understand what it's doing, because your fancy calculator has an option for this. So if I asked you to find the number of permutations of 5 objects chosen 3 at a time, 5p3, I'm going to go ahead and type that into my calculator like so. So I start with 5 objects, so I'm going to hit the number 5. Oops. Again. I type 5. And now I need to find that permutation option. Now a couple different ways to get there. Easiest if you have the new operating system is once again hit alpha F2. The 7th option is NPR. Now you don't necessarily have to type the 5 in first on these newer calculators. If you have an older calculator, you have to put the 5 first, then choose the NPR command, then put whatever R might be. Newer calculators doesn't matter, but we'll choose the 7th option here. So it automatically takes the 5 and drops it down into that subscript that comes before the P. So that's the number of objects that I'm working with. I then fill in the R. Well, I wanted 3 of those objects, so I type in 3. So 5p3, I've got 5 objects and I'm going to put 3 of them in order. How many different ways can that be done? 60. Now, does that match up with what we might think? I don't know. Let's find out. 5p3. According to our formula, this would mean take 5 factorial divided by 5 minus 3 factorial. Well, that'd be 5 factorial divided by 2 factorial. 5 factorial is 5 times 4 times 3 times 2 times 1. I might as well write out the whole thing. 2 factorial is 2 times 1. I could cancel the 2s, I could cancel the 1s. 5 times 4 times 3, well, 5 times 4 is 20, times 3 is 60. That's the same thing that our calculator spat out for us as well. So, pretty easy to do permutations on your calculator, especially if you're simply given the notation. So, 4p1, type it in. 8p5, type it in. No worries. The last thing we're going to look at is permutations where there's repetition involved. So first thing I want you to do is, if you consider the letters E and E to be distinct, as in there's a red E and a green E, there are 6 permutations of the letters red E, green E, and blue Y. And I'll show you how this might work out here. So different ways this could be written. I could have, let's put the red E first, and then we'll have the green E here, green E here, and we'll put the blue Y at the end and the blue Y here. So there's 2 different options we've got. Next, I'll put the green E at the beginning. I'll put the red E here and here, and the blue Y here and here. So now we're up to 2 more options, so we're at 4 options total. Last one, I'm going to put the Y at the beginning. I'll put the green E second, the green E third, the red E second, the red E third. So 6 different ways that I could put those in order if I consider E and E to be distinct, because I said, hey, this one's red and this one's green, so they're different things. That being the case, again, 3 distinct objects, this would be equal to 3 factorial. 3 factorial is 3 times 2 times 1, that's 6. Same as we've been working with. Now, if the 2 E's are considered interchangeable, they're not distinct anymore, then there's only 3 ways to do this. It would be E, E, Y, and E, Y, E, and Y, E, E. That'd be it. No other ways to do it if the E doesn't have a color that separates it one from the other. Well, how do we get that? Let's see. We have 3 factorial, which gave us 6, but now what happened is we took 3 factorial and we had to divide it by 2 factorial. 2 factorial is 2, 3 factorial is 6, 6 divided by 2 is 3. There's 3 ways to do this. So this is an example of a permutation with a repetition. Now the rule for that is down below. Permutations with repetition. The number of distinguishable permutations of n objects, where one object is repeated s sub 1 times, another is repeated s sub 2 times, and so on, is equal to this that you see right here. Now it's kind of hard to read. I'm going to write it a little bit bigger. N factorial, so whatever number of options there are, that's great. Divided by s sub 1 factorial, so meaning if there's something that's repeated twice, I have to put it there. If there's another digit or letter or whatever it might be that gets repeated, I have to put that there as well. All the way down to some random number of options repeated. Now, to give you an example of how this works, I'm going to ask you, how many different ways could we rearrange the letters in the word Wisconsin? Well, according to our rule, first we need to figure out what n is. How many letters are there in Wisconsin? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. 9 factorial will be the numerator. But then I have to divide by the repeats. Well, let's look for some repeats. First of all, I notice that there's 2 i's. So because there's 2 i's, I'm going to have 2 factorial in my denominator. What else? Let's see. I notice that there's 2 s's as well. Okay, well that's going to be another 2 factorial in my denominator. And these get multiplied together down here, according to the rule. Anything else that overlaps? Oh yeah, I notice that I've got 2 n's. So I'm going to have another 2 factorial in my denominator. And I have to multiply all of those together. So I take my 9 factorial divided by this product. 2 times 2 times 2 is 8. 9 factorial divided by 8 is going to be, I'll let you figure that out on your own. But that's how you would work with permutations where there are repetitions. And you'll get some practice on that in your assignment. And that's it for lesson 1 in chapter 10.